All right. Graphing quadratic inequalities. So if they give us the equation y is greater than negative x squared minus 2x plus 15. And actually, I don't want to do that one because that's not going to fit on our graph. Let me grab a different one real quick. Y is greater than or equal to negative 2x plus 9x minus 4. Sorry, 2x squared plus 9x minus 4. Let's do that one. Okay. There's some things you should be able to look at that, or one thing for sure, and you need to think about right away before you start doing anything. When I graph this, is it going to be a solid or a dashed line? Solid. Okay, you need to know that. Okay, you have to understand whether it's going to be solid or dashed. Okay. The next thing we got to remember is, how do I graph this? How do I graph a quadratic? I got to find I could find the x-intercepts, but it'd be a little bit harder to factor this one than I really want to mess with. I need to find the vertex. Negative b over 2a. Good. It's been a while since we've used that. Now that's just going to give me the x value of the vertex, right? Okay. So negative b is
9.
Negative 9 over 2 times negative 2. So I have negative 9 over negative 4, which is actually positive 9/4, correct?
Yes.
Great, I picked one that's going to give us fractions right off the bat.
Isn't that just
It's okay. Okay, you're going to have to do them in your assignment.
Okay.
Okay, so you have to go do them here.
Okay.
Do it by the marker. There it is. All right, so now that I have the x value, I need to plug it in, right?
Yes.
Okay, so I have negative 2 times 9/4 squared plus 9 times 9/4 minus, now I'm going to go ahead, actually I'm not going to mess with that yet.
Good idea.
On this one, if I were you, I'd honestly probably, once I get to a point, I'd plug it into a calculator. But 9/4 squared is 81 over 16 plus 9 times 9 is 81 over 4 minus 4. Let's go ahead and distribute or multiply this. So negative 2 times 81 is negative 162 over 16 plus 81 over 4 minus 4. Instead of messing with common denominators, what did I mess up?
Where did 9 go?
I multiplied 9 times 9/4 and got 81/4. So with this big of numbers, I'm probably not going to mess with trying to find a common denominator and doing it by hand. I would use a calculator.
Why wouldn't you multiply the 2 by the bottom? Because it's 2 over 1.
Because it's negative 2 over 1.
Oh, yeah, good idea.
Okay. So when I type this in, this is how I would type it in. I'd put that in parentheses. I'd put a plus sign. I'd put that in parentheses. I'd put a minus sign, and then 4. Okay. You should be able to type that straight into your calculator at this point. So I have negative 162 divided by 16 plus 81 divided by 4 minus 4.
49 over 8.
6.125, which is 49 over 8. Okay? Now, again, they're not asking for that, right?
Nope.
You just have to have an understanding of where that's at. Okay? On your problems, on your assignment, you're not going to have to graph that vertex, because we all know that Big Ideas only lets you graph in whole numbers, right?
Mm-hmm.
Okay? You're obviously not going to have to graph that vertex, but we should be able to do it here. Okay, 9/4 is 2 1/4, So I need to go over 2 1/4, and then this was 6.125.
Yeah.
So then I need to go up a little over 6. Okay, so for our purpose, that's going to be where our vertex is at. Okay. So after doing all that, finding the vertex, what do I do next? They're not always going to be that hard. Yeah.
Do we have to put it like in fraction or? Can
No, that's what I'm saying. They're not going to ask for this answer. I don't care if it's decimals, fractions, whatever. I don't care. Okay, and if you are actually putting points on a graph, they're not going to be fractions because Big Ideas isn't going to do it in fractions. Okay. So now I got to pick more points, right? Okay. I'm going to avoid 2 and just go straight to 1, just because it's going to be really easy to plug in, right? Okay. So I plug in 1. I'm going to erase this just so it's out of our way. Is that okay?
Yes.
Okay. So I plug in 1. 1 squared is 1. Negative 2 times 1 is negative 2. 9 times 1 minus 4. So I have negative 2 plus 9, which is 7 minus 4, 3. So when I plugged in 1, I got
3.
Okay. What's another easy one?
Wait.
0.
I'd probably try 0. Okay. So 0 is going to give me. What's that?
-4.
It's going to give me negative 4. Okay, so at 0 I have negative 4. So that's on the left side of my parabola. How do I get the right side?
You just
Reflect.
I reflect it. Okay, this one's going to be a little harder just because it's at a weird point. I'm just going to put it over there for now. Okay. Okay, so we got our rough graph. Again, yours is going to be, they're probably going to give you like 4 or 5 graphs to choose from. You're going to have to choose the right graph. Okay?
Okay.
So I have this thing graphed now. Did I use the correct type of line? Or should it have been dashed?
Nope, you're good.
I'm good. Okay. Where do I need to shade?
Outside.
Why?
Because it gets bigger
My
outside the
y's
graph.
are getting. I want my y's to be more, right?
Yes.
My y's are more
Outside the
out here because this is crossing over, and my y's are continuing to get more negative, right?
Yes.
So I need to shade on the outside where my y's are more. We good?
Yep.
Do I need to separate already? Don't worry about it. Just pay attention, take notes. Okay. Any questions on anything that we did on that one? Okay, you're not going to get the fractions. That just happened. I just pulled one out of the book. Okay, you're not going to get the fractions that are that crazy all the time. Okay, and if you do, they'll have to give you multiple choice because you can't graph fractions on Big Ideas, right?
Yeah.
All right, so going on, continuing with that, looking at example 2, and my example's a little bit different than yours. Okay. The example I'm looking at says the allowable bending load M in pounds of a certain size concrete beam can be expressed as M is less than or equal to 540 D squared, where D is the diameter of the beam. Okay. So what this is telling me is I have this concrete beam and it can only bend so much with so much weight. M is mass. Okay, it can only bend so much before it breaks, right? Yep. Okay, it's like whether it's on a bridge or whatever it is, it can only hold so much weight before it breaks. Okay, and this equation is demonstrating that. Okay? D is the diameter of your beam. Okay? They want us to graph this inequality and then interpret the solution. Okay? So before we get to interpreting anything, let's get this thing graphed. Now, knowing that this is real life, real world stuff, is it possible for M mass to be negative? No, that makes no sense. Is M in place of X or Y?
Y.
In place of Y. So instead of Y, I have M. D was diameter, right?
Yes.
So that must be X. Is it possible for a diameter to be negative?
No.
No, that doesn't make any sense. You can't have a negative diameter. So I know that everything that we are going to be doing is going to be in quadrant 1, right?
Yes.
You guys good? Okay, everything has to be in quadrant 1. Correct? Everything has to be positive here. Okay? How am I going to graph this? Because on the last one we did negative b over 2a, right? There's no b. It's 0. So if I did, I could do, if I wanted to, plus 0d plus 0, right? What is the x value of the vertex going to be?
0.
It's going to be 0. Okay? That's going to happen a lot for you on these word problems. Okay, the x value is going to be 0. Well, if I plugged 0 in, I would get 0. So where's my vertex at? 0, 0. Okay, so here's my vertex. Okay. So if I were doing this, one point would be at 0, 0. How am I going to find another point on my parabola? Pick one. Easiest one probably is 1. 1 squared is 1 times 540. 540. Now, just looking at that, it went from 0, 0 to 1, 540. This is probably going to grow pretty fast, right?
Yes.
I would say
So I'm not going to graph these yet. I'm going to find 2 more points and figure out what I need to change this scale to.
Okay.
Because I'm going to have to change it, right?
Yes.
Okay. So let's do 2. And I'm going to need somebody to have a calculator available. 2 squared is 4.
160.
2,160.
That's what I got mentally.
Okay. And then when I plug in 3, let's do one more.
4,860.
Thank you. Okay, so I have 4 points. So is my diameter axis okay?
yes.
Yes. What would you change your mass axis to?
Probably 540.
Yeah, go like 500,000.
You go 500? Okay. So 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500, 5,000, right? Okay, that'll work. So now I should be able to get this graph, right?
Yep.
Okay, so I graph 0, 0. I graph 1, 540, which is almost there.
What?
That's probably something.
Yeah, you're right.
That's too high.
It's probably somewhere like there. Thank you. 2, a little over 2,000. And 3, almost 5,000. Right?
Yeah.
Yep. And it's this one.
Am I okay doing a solid line like I did?
Yes.
Yep.
Yes.
Now you just have to reflect it.
Now I don't need to reflect
only
it,
using- you're only
but you
using the-
could. If you were graphing it and it was not one of these real world problems, you could reflect it.
You're only
right?
using the one quadrant,
I was
aren't
like,
you?
oh.
Where do I need to shade?
On the left. No. Yes.
On
outside.
outside.
It's outside because.
Because if you would do the other side,
If I were to do the other side,
it would be getting smaller on the outside.
it would be less out here, right?
That's how exact.
Everybody agree?
Yeah.
Does anybody not see that? If you reflect this, my y's are less out here. Okay, so I would shade
To the right.
outside.
Below.
Okay? So, what is this telling us? They want us to interpret this. What is this telling us? Remember, D is diameter of the beam, M is mass.
The bigger the diameter, the bigger the diameter of the beam, the more weight it could hold.
Exactly. The larger the diameter of the beam, the more weight it can hold, right? Okay, so here's a question. If the beam was 2 inches in diameter, could it hold a 4,000 pound or 4,000 pounds of weight?
Nope.
No, because at 2, 4,000 is outside of our solution area.
I mean, it could hold it for a hot second, then it'd be. I don't think
For a hot second.
I'm going to go ahead and say no, it can't hold it. Based on this equation, it cannot hold that much weight.
It can hold it.
It could hold
Maybe
it for a
like
hot
dropping it
sec,
down.
and then
Could.
it would be
As
dead.
it's breaking.
Yeah.
That's
That's
with
what I'm
me?
saying.
Yep.
If the diameter was 2, could it hold something that weighed 2,160?
Yeah.
Wait, it can?
Yes, because it's
Because
more equal to.
it's a solid line.
Okay.
If it were a dashed line,
Then no.
the answer would be no.
Because then it would have to hold greater, like
Okay.
No, it would have to hold less than 200.
Right.
Whatever.
So be aware of that. That solid or dashed line makes a huge difference. If it is solid, anything on the line does work. If it's dashed, anything on the line does not work.
I have a question. So what if you have like
Go ahead.
if you have the dotted line, like how do you decide, like if you can't tell by looking at the graph which side of the dashed line the point is, you know what I'm saying?
Pick a point. If
Okay.
you can't tell, pick a point. Now here, you can't pick 0, 0 because it's part of your graph.
Okay.
So I would pick 1, 0. Okay? So I would be over 1. So I would have this. I would pick x is 1, my y is 0. This would be the point 1, 0. I'd be plugging it in. It'd be right here.
Oh, okay. And then like if it's true.
If it works, if it's true,
Okay.
that's where you shade. If it's false, you shade the other place.
What was it my question?
What was your question?
I said like if you're trying to find a point, if it's on the inside or the outside, like
Never mind.
I'll figure it out.
Don't listen to her.
You just interpret the graph. That point's on the inside.
No, that's what I'm saying. What if it's like you can't tell? Like if it's like a dotted line and you just can't tell, will that be a real thing?
No.
Okay.
You're confusing yourself.
No. Okay. Last example I have here, example 3. Okay, they give me 2 equations. So now we're solving or we're graphing a system problem. They give me that, and they give me that y is greater than or equal to x squared plus 2x minus 3. Okay. All this means is you're going to graph both of them. Your solution is going to be where the shading crosses each other. Okay? So, first graphing this, my x value is going to be what of my vertex? What's b?
Zero.
B is just 0 because there's no actual x, right? So if b is ever 0, your x value is automatically 0. Okay? So my y value when I plug in x, 0 squared, 0 plus 3, my y value is 3. Okay? So I have a vertex at 0, 3. To find more points, I need to plug in some other x value. So I plug in 1. 1 squared is
1
times a negative. Negative 1 plus 3, 2. So at 1, I'm at 2, and I can just reflect that. 2 at 2, 2 squared is
4.
so a negative 4 plus 3, negative 1. And I can just reflect that. Should this graph be solid or dashed? Dashed, good.
That looks good.
Okay.
Looks great.
Where do I need to shade if this says y is less?
Inside. Because it's going down.
Where are my
Yep.
y's getting less?
On the inside of the
On
parabola.
the inside of the parabola.
Good job, Miranda.
Okay, so I'm going to shade on the inside. And this is going to show up better actually on your guys's because you can shade lightly with a pencil. Okay, my markers don't do light. On this one, what should I do?
It's 0 again.
No, it's not.
It's 2.
Negative
Why?
b is negative 2
Oh, yeah.
over 2 times 1.
Oh, just kidding. It's negative.
I was looking at the first
It's
one.
what, Regan?
Negative 1.
Negative 1. Okay. So negative 1 squared is 1. 2 times negative 1 is
Negative 2.
negative 2 minus 3. So 1 minus 2 is negative 1
And I got that.
minus 3.
Negative 4.
So at negative 1, I need to go down 1, 2, 3, 4. There's my vertex. Okay,
Wait,
now,
you can overlap in each other?
yep. So now the next thing I'm going to do, I'm going to jump right to, if you remember this, and we didn't talk about it up here, but this is a y-intercept. You guys remember that? Your C is your y-intercept. So I'm going to jump right here. I know it intercepts at negative 3, which automatically gives me a point to reflect. And then, remember that? And then do one more point.
Wouldn't 1 be 0?
1 squared is
1,
2 times 1 is
2.
1 plus 2
3.
minus 3.
0.
So at 1, I'm at 0. And then go ahead and reflect. So,
Do I have anything today?
yeah, I got actually lots of copies I need made. You don't need to do them today if you don't want to, though.
Can I do them on Thursday?
Yeah, that's fine. See ya.
Bye.
Solid or dashed?
Solid.
Okay. I need to shade where my y's get bigger. Do they get bigger inside or outside? Inside. Okay. So I'm gonna, it looks like a mess up here. I'm gonna go through our solution area with blue. So it would be solid here, right? It would be dashed here. And then it would be everything in the middle. It'll look.
Do you have to do that?
Well, yours will, if you shade it in pencil, like if you're doing it by hand and shade it in pencil, that's just going to be a little bit darker than everywhere else after you shade. Now, on your assignment, no, you're obviously not shading with a pencil or marker, right? You're going to have to select the right graph. Okay. That's just, all that is, it's doing the same thing we did on example 1, but with 2 of them. Okay? So I need you guys to finish through problem number 25 for tomorrow.